Good evening, everyone, and thank you for joining us for tonight's V Brown Bag. I'm your host, Tom Green, and tonight we're going to be talking about infrastructure as code with Brett Johnson. Before we start, we'll do a little bit of housekeeping, and tonight we actually have some new news. We're including the V Brown Bag Brazil information on our side. So if you haven't heard, we have a new V Brown Bag presentation that's out of Brazil, so you can check out their schedule on vmware.com/vbrownbags with everyone else, and also follow them on Twitter. Speaking of Twitter, I'll be managing the question and answer portion of this, so if you'd like to join us, to get in, to ask some questions, please tweet the hashtag VBrownBag or use the chat if you're watching live. So without further ado, I'll hand it over to Brett. How you doing, Brett?
Yeah, doing well. Just middle of the workday for me, so I think it's pretty late at night for you guys. But yeah, doing good.
That's one of the benefits of being in the future, I guess.
Yeah, kind of, except if you're at client premise, that sort of thing makes it a bit more difficult, but it is what it is. So I'll just...
All right, so you should have control now.
Yep. So you should see my screen there.
Yep, I got it.
Cool.
You're good to go.
Awesome. So we've already had the intro, so let's get that out of the way. So tonight I'm going to be presenting on as an introduction to infrastructure as code, so going through some of the concepts about it, that sort of thing, ways to implement it, some of the challenges and advantages with taking this approach. It's not going to be a technical deep dive, more of a high level areas where you might want to consider when you start off doing this sort of stuff. So I work as a senior consultant, and my Twitter handle is on the screen, is BrettJohnson008, and I've got a blog which I frequently update. I've got a couple of repos on GitHub, just bits and pieces that I've been doing, and yeah, I like my coffee black, and I'm a bit of a nerd. So, infrastructure as code, basically, we'll just quickly define it. It's more than anything else, it's more of a strategy on how you're going to implement and manage the life cycle of applications. So it sits above, to an extent, it can sit above the actual infrastructure itself, despite being infrastructure as code. So it's how you configure things. It could be the actual infrastructure, the networking devices, that sort of thing, or it could be the applications that sit above it and how they consume it when they're deployed. It's very much a business process. It's not just about, hey, let's put everything into code. You need the business to understand that this is a different process, and that can also be one of the challenges there. So when you get into infrastructure as code, it's the whole idea is that you, from end to end, from deployment to disposal of a application or a service, it's all done in code. You don't go manually and update things. This, in the real world, isn't always the case, but it's the intention of infrastructure as code. Usually it's done by declaring a desired state, and I'll touch on that, I think, in a couple of slides. But at a very high level, it's saying, well, when this is done, what should it look like? You describe the end state, not necessarily the entire process. There's three main approaches to running infrastructure as code. There's the declarative, which touches on that declared state that I mentioned before. So this is sort of quite an abstracted area in terms of, I want a cake, and I want it to be in the shape of a race car. That's declarative. You go into a shop and you say, this is what I want the end state to look like. You may say, I want a chocolate cake in the shape of a race car, but it's very much, I want this like this. It's declared. Imperative is more procedural, where you would say, if you're doing this, again, sticking to the cake scenario, the procedure will be, I go to a bakery, or I call the bakery, or go to the bakery. I ask for the cake, and I describe the shape of it and the flavor, and I pay for the cake, and I pick it up. That's more of an imperative. It's step by step in the order you do it. So if you're going into an imperative way, you mix up the order. You can't say, I pick up the cake, then I call the bakery. and you need to declare that in your code. When you go imperative, you specify the steps, whereas where you go imperative, where a declarative is just, this is what it should look like. And intelligent is more about environmentally aware. So if something happens, and this is sort of you can consider it as a bit of an automated remediation point of it as well, or if something happens on one area, that it intelligently updates another area. When you do declarative, usually you're going to be using a resource or a module, which is imperative. So it will help work that area out for you, but it's abstracted that away. Now, some of the advantages we've got here is version control allows for very high quality and granular tracking. So with proper version control standards and processes in place, the ability to understand where a change has it by line or character by character in the code is quite easy to track. And the code, in a way, is self-documenting. I'm not a big fan of that term, to be honest. I don't think self-documenting is a great term, and also has a lot of misrepresentation. But the idea behind self-documenting in the term is that what's written in the code is what happens. Obviously, this is bugs and that sometimes don't exactly allow that. But if the code is fully vetted, so you've got all your operators, or you haven't made typos, that sort of thing, then what happened, what you expect, or what is written in the code is what happens. So it's not like, I'm intending for this to do this, but I put in a problem, or I typed it in incorrectly. Because you typed it in incorrectly, that's what happened. So it's not what you intended, it's what's written. Deployments generally are faster. This is the reason why I say generally is, especially when you're starting, it can take longer because it's a big shift in the way you do things. But generally speaking, the deployments are faster because there's no manual steps. If you're deploying six servers at once to form an application stack, it can do a lot of that deployment and configuration in parallel. So it makes big advantages there. And then it may deploy all the servers blank, and then you can put depend areas into your code. Instead of saying, wait 60 seconds, you can have it depend on something to be completed before it does its next step. And that means you can get all this stuff up. Like if you've ever worked on a workbench doing configurations, you've got 6 laptops in front of you, and you type command in one, you move to the next, you do, and go through all 6. It kind of does that for you. And then, oh wait, I've got to wait for this to happen on something else. It's going to stop, and when it gets a notification that something's completed, that it's depending on, it will just start off again and continue on that process. So that's where it can become a lot faster. Tests can be built into, and should be built into, using infrastructure as code practices. This is to verify code and the actual deployment all the way through, and there'll be a lifecycle chart thing I've got a picture of coming up soon, which will help explain that a bit further. But essentially, when you've written, when you write your code, before locally on your computer, you test it, or you write your test first. So you might have a function that says deploy this, but before you write that function, you write a test saying, well, this function should do this. And you write that function so it passes that test, and that test can then be reused. And through some other practices, you can have that part of the actual, what's called pipelining of the code, where it goes from the development on your workstation, and it will actually do that for you. So it means you're not going to skip the tests. Also, those tests can be used for operations to support it. But if you've deployed your infrastructure as code, because the code is saying what that infrastructure is, and every update goes through that code, it means that if there's a fault on the server, those same tests, like a ticket gets logged, your ticketing system could kick off a request to run a test, to do a dry run from your configuration manager or maybe a compliance system, and say, well, does this meet what it should meet? I.e., has somebody gone in there and manually updated a DNS server? And then it will run that and say, well, no, the DNS server should be this and it's wrong. And it makes that troubleshooting process a lot easier. So there are reuse advantages to some of this as well. Now, depending on the scope of what you're doing and what you're working on, you can have your test environments automatically built. So it will build the environment, run the tests, so run the code, and then tear it down. And there are some limitations to this. For example, if you're using switches and like if you're doing some network automation and these functions require physical ASICs and they're proprietary and you don't have the SDK for it, you can't really spin that up. If anyone's used GNS3 with Cisco devices, and you see that there's a lot of layer 2 functionality that's not available in there because of that ASIC dependency, this is where that can come into. Whereas if you've got network operating systems such as Cumulus, for example, which can be agnostic, and again, where they can be a bit agnostic from the switch, it could be spun up as a VM to run that test and to say, hey, did this work? And with that test environment, you might be changing one switch in a cluster of 6 or adding one or removing one, and it can perform those functions. So it could spin up that whole environment, then add another switch and remove one, and that comes down to that automated testing. You do get to put fancy DevOps stickers on your laptop, wear horrible hats, get bad fashion, and go to conferences if you feel like it. That's always an advantage of this, I guess. DR can be, to an extent, DR can be simplified. So, for example, of one of my clients, they have an application where the primary database is replicated between like 2 sites, and that's fine. The other services, they don't need to be backed up and worked in a traditional failover plan in terms of, okay, let's replicate these application VMs. If a site goes down, it will, spin up that VM in its last backed up state and attach it. Through infrastructure as code practices, instead of that, they can just rebuild it. So over the course of within an hour, it could rebuild that application state because all those changes have been made in code, and the last known state is what was written in code. So it will go up and it will connect to that database. Now, the reason why I say can is some things don't support that. Some applications you simply cannot do that. And this doesn't also cover things, for example, if that database was corrupted, it doesn't cover that. So it's not does everything, definitely doesn't, but it can help. It can be another area where this makes your life a bit easier once you get used to it. In terms of challenges, there's a lot, and a lot of them are sort of more, I'd say they're more business than technical. And the reason is technical, generally speaking, isn't the hardest thing to learn. You can learn syntax, you can, you put time into it, you can learn it. You put time into learning a tool, you'll learn the tool and how it works, what its limitations are. But business, on the other hand, isn't quite as simple. You might have something that does, you might have a process that if you did it through a infrastructure as code practice, it takes 4 hours less time, and out of a 5-hour task, that's a huge difference. However, because it's an entirely new process, it's untrusted, businesses can see that as introducing risk, which is really hard to convince change control about. Like, if you go through and say, well, we want to move it to this way, and they go, whoa. No. You got these are our processes, because the irony is that change control boards don't like change, especially to their processes. And this is an entirely new process end to end. It's not just, hey, yeah, let's allow someone to self-service a VM. This is more around, okay, well, you don't log on to the VM and run the RPM or the MSI file to do the update. You get the update pack and you convert that into code, and that process and will copy it across, and it will run the commands. It'll do the install. It'll run the verification tasks, and it's end to end. So when you destroy it, it then might go and remove it from DNS. So it's a big challenge, and that's not generally, if you're working in this, it's probably not going to be limited to yourself. It's going to be very much around a whole team. So you might need 3 or 4 people to get on board with that, and it's really quite hard. People, you might be championing this, and the other people might say, yeah, cool, that's great, but they're not comfortable with it. They get a lot of what if we don't put enough validation tests in there? What if we don't what if I don't understand it? What if you're away sick and we have to support it? How are we going to document it? People get uncomfortable with new practices, and this isn't just, hey, here's a new application. You still just install it by going next, next, next. This is, I have a PDF that says I go here and I do this, and then now I have to take that and I have to write that into a configuration manager, and I have to create security groups on my firewalls, and I have to write a configuration to do that. I have to talk to my load balancer and create a VIP, but I have to translate what is in a PDF, a simple PDF which is designed about deploying through the user interface, and I have to convert that into code, and it's a big jump, which also means it's very slow to start. So when you start this, you need to get used to breaking down things and what steps are going to need to be, what steps are required to actually do the process as a whole, instead of just following a guide and somewhat blindly at times. So that slow to start is, I think it's usually referred to the trough of disillusionment, which I should probably put an image in, but hey, I've got to do that. And it is going to be slower to start, and it's hard to see the value when it's slower. Over time, as confidence and experience grows, it gets faster. People become more confident with it as you go. And business needs to be confident in the approaches. They need to be confident that you've done a good job validating it, having practices in place to ensure a reasonable degree of success. Now, I'm not going to say guarantee success, because there's, no matter how well documents are and practices are, there is always the chance that things go wrong, because, I don't know, solar flares and monkeys and whatever else. And usually, because we do in the sort of the open source area with this, there's going to be a lot of tools. It's not just, hey, let's use this tool. It's going to be, well, I need this tool for my F5 load balancers, and I need this tool for my my hypervisor, and I need this tool to string them together. There's going to be multiple tools to learn. You can do parts and do bits and pieces and grow into it, but it's still a challenge. Oh, and also, every tool in this area is always the right tool for every job. And yeah, so it's hard sometimes to work it out until you actually just try it. So because we're dealing with code, there is a lot of programming practices that need to be adopted, and there's more dev in here than there is ops, especially when you're coming from an operations point of view. The ability to say, this is a task, and then break that task down into the 75 different components, and you might not know how to configure the storage side of it that's required, because it needs dedicated storage or the storage policies. So then you've got to go talk to other departments to understand it and put that into code, and that can be rather difficult, especially when you want to verify. There's a big difference between just, hey, it does this because I wrote it, but how does it do it reliably? How does it detect if this is how it should be? How does it detect what the difference between a successful and a unsuccessful failure? Programming practices are a big thing here, especially in a team environment. So if you work on this alone, if you've done this sort of like scripting and that sort of thing alone, where you sort of do your own thing, you don't have any dedicated practices, and then you work with someone else on that script, someone else comes in, and they think, I'll add some functionality to this, and you might see that there's a huge difference in code styles and names, and it can make it quite hard to read. And when you deal with a team, this is where at the start of projects or as a whole that there are certain styles that need to be adhered to. For example, do we use tabs or spaces, 2 or 4 spaces for when we indent? How do we name our variables and our functioning? How do we name them? Are we going to do the verb noun? Or when we do variable names, are we going to use camel case, which is each word starts with its own, each word starts with a capital, but there's no spaces? Are we going to use hyphens or underscores, depending on the language? Are we going to use double or single quotes? Some languages that is important, some languages that doesn't make a difference. And these are those things where ensuring it's consistent allows the code, one, to be understood by everybody easier, and where if you have to parse it or move it from one thing to another, your results are going to be more consistent as well. How do we do our tests and those sorts of things, linting, so that which comes back to the style. These are areas which are very much programming practice, but need to be adopted for this sort of infrastructure as code. Now, understanding operations is a really important part. As much as this is development, it is really important to understand operations, because in my experience, I've generally found that operators are usually better at asking those questions, which developers sometimes miss, of what's the impact? What does my service dependency tree look like? And how does this talk to that sort of thing? Just as a generalization, is generally those questions usually are more likely to come from an operator. So having that operations understanding is still important. It's just, if we're going from one to the other, the thinking change will be to a programmer. Okay. Version control is a huge part of infrastructure as code. It's a huge part of code in general. When you start dealing with version control, there'll be a lot of different terms and a lot of different ways to do things, and it can be fairly complicated. I can't remember how many vBrown Bakes on, but we've done a few commitments, so about using Git, and we've got quite a number of videos just around that alone, and that, to give you an idea of how complicated it can be.
Yeah, I think we have like 4 or 5 years worth of playlists for that.
Yeah, so yeah, it's a lot. So there's a lot of detail there. You look at it and you can say, yeah, I'll do git commit, and that's fine. I'm using version control. But then there's that strategy around, okay, well, if there's a merger conflict, how do we understand that? And again, as a business process, what is the standard practice for dealing with a merger? And when you work in a team, you need to coordinate that between everyone. When it's just yourself working on it, well, really, you shouldn't have any conflicts because you're the only one working on that specific piece of code. But if two of you work on a file, there's that conflict change. So that's where it can become quite challenging. Now, Git is, generally speaking, the most common version control platform, and GitHub's probably I'd say the most common version control repository. Now, there are other ones out there, usually based on Git. And if you go down that route, you can have publicly hosted one with public repositories, which everyone can see, or you can have private ones on a public host, or you could just do it. All these can be internal as well. And part of the version control disciplines, as well as when we move this to production, you generally should be specifying the exact version that you want to go to production. So instead of just saying, hey, latest, then there's that sort of area there, as well as ensuring things such as do the SHA or the file hashes, whether they're SHA or MV5, whatever you choose to use, you need to make sure they match, because that's where you want to ensure that as part of your validation that you are running the right code. Now, when you use a version control platform such as Git, the idea here is that it is going to work sort of at the code level in terms of each item. So if I've added something to my configuration manager, then I may do 20 or 30 updates. I just want to add a couple of services to my configuration manager or a couple of checks, but I might do a large number of updates. So if you look at most of your software, you'll see like a version number, usually 3 octets plus a build number after the end. The build number is more usually in reference to that sort of change than just the actual version number. But within that, that's one area of the version control. But in your application, what you end up pushing to the application service, for example, if you still work with like a configuration manager example here, the configuration file that you're going to push may only go from 3.0.1 to 3.0.2, even though you've made 30 commits. So there's a difference here. And when it goes to production, you may want to specify use this specific version. So that means that if you roll back, you can go via that. You can go via the version in the application, whereas what you actually work on from a code point of view is more around the actual version, the Git repository versioning. Usually small commits are better than a few large, and the reason for this is if you make mistakes where you want to see the difference between one mistake and another, or one where you're working on something, you do make a mistake, you want to be able to see that, oh, yeah, this was the line, not this is one of the, it's one line in this lot of 500 that changed it. So, and then you can get your commit comments a bit better scoped for what you're working on. Now, sometimes you may want to leave your commit until you have a function in there. But this is also, there's a difference then between where you commit locally. So you say, hey, look, I've made a change and I'm happy with it. Oh, I've got to go to lunch, I'll just commit that in. And that may just stay on your computer. But when you go push that now to a remote repository for everybody else, that may just be a larger one, but it will still include your whole commit history from locally.
Yeah, the worst feeling is when you need to revert and somebody's pushed 60 or 70 changes in one commit.
Yes.
Have fun digging that one out.
Yeah, not a big fan of that one. My usual approach to that is, for example, if I'm working on a function, I'll make commits as I go locally. And then once I've got the function working and I'm happy with it, that's where I push it up. So they can say, hey, look, yes, I've done 20 or 30 small ones to get this, but what is actually pushed into the remote repository is just one additional function. And that, again, comes back to that principle of what's the business process, what guidelines should you set for team members to manage that so it's consistent, whether it is, yes, just do heaps of small ones to the remote repository, or just once it's done, tested to a certain point, push to remote. So this is sort of the whole process of infrastructure as code that I stole from rightscale.com there. So I better give them credit for the image because I just blatantly stole it this morning. So from a continuous build point of view, this is where you've done your source code, you've committed it. As part of that commit, it's going to provision and automatically build it and do a report. So it's going to say, hey, look, I've spun up these switches and this server, and I've provided some storage to it, and maybe I've grabbed the database from our last backup through a live mount system, and now I've run tests. I've said, can switch A talk to switch B still, and the test can depend on the scope. So if you're doing a whole new stand-up, you test more end-to-end, whereas if you're just to change to the application, well, you may spin up everything for it. You may just run the application-based test. Now they could be tests that just do some API calls. Can I write to the database? Can I do this? Has this change impacted the disk space? Is there still enough disk space available? You can go through all those sorts of tests. And the big part here with this is that you've got a difference between when you do the builds in terms of, is it integrated? So a integration test is does it work end to end, or a unit test, which is, did my function work? So when you write a unit, when you work on a function, it's like, if I have a function that adds 2 numbers and your test would be, well, if I send 2 and 2, does it give me 4 back? Whereas as part of this process here, that should have already been done. And then it comes down and says, oh, yep, that worked. And then if the builds, that's from the build point of view, but from a integration point of view, it's still going to do the same sort of things, and it's going to test it, but it's more about where you're now integrating instead of just building, and the delivery is where it goes to prod. So you might build it and then I say, yep, the build's fine, but let's now integrate it with something else, or we're doing it as an update. It's more of an integration, and we go through the same process essentially. And then if all that passes, then you deliver it into production. Ideally, everything's fine, it's success and it stays there. If it doesn't, then it needs to be able to roll back, and you need to have plans for if it fails. And if it's a first deployment of something, a rollback's easy. It's just scrap it, delete it. If it's a update, well, then you need to understand the scope of the update, and it may be, I've changed a DNS server or an NDP server. Oh, now it's failing. Let's let's just roll back to the last version because that was still working. Or if it is something where it updates the database schema and that sort of thing, there's different planning around that that needs to be taken into account.
So we have a question that's come in.
Mm-hmm.
Do you have a good guide for Git best practices? Maybe more than just like how to do it. Like Commitmist covers a lot of how to use it. I'm sure there's some videos on best practices there, but
I can't think of a link off the top of my head. I've usually just gone through the Commitmist videos, and then for me it's usually a sort of a Google thing, Googling and sort of going down there, making it up as I sort of go along and help people to sort of adhere, and it seems to be working. But I haven't worked in a large scale developer area to be able to say this is a really good development practice for Git. So from a small scale, it's usually a bit more ad hoc, and these are some good ways to do it.
Yeah, I'll try to, if you watch my Twitter, Graham, I'll try to tweet out some videos and stuff that I've used, but I don't have any references either.
Got a couple of others popped up. Bringing up a team of 20 programmers.
Yeah. So
yes, moving from SVN. Yeah, that's going to be.
Good luck.
Yeah, it's for me really a lot of the practices is around about okay, what suits the business. They're going to vary a lot of your practices in terms of what's acceptable. Are they on different time zones? What level of scope do you want to have? Pipelines where before you do Git has what's called hooks, where you can do hooks at certain stages of the commit process and the push process, where you might integrate that with Jenkins or something like that to run tests. It's sort of I don't have anything off the top of my head though. Sorry.
My one best practice would be use branches, if not forks. Do not commit straight to master.
Oh yes, God yes.
even in your own personal GitHub.
Well, are you saying you've never? I've never blasted away master because I completely screwed something up and had to rebase. Never ever done that. Okay, maybe I'm lying. So with infrastructure as code, it is a bit different to where you might have a traditional script in terms of I'm going to provision a VM. So here's a PowerShell script that talks to my vCenter server and provisions a VM. That's a very procedural sort of scripting approach where it's okay, well, it's done that and that's its task, and it doesn't really go to the next step of how to deploy the application. Whereas in terms of infrastructure as code, it's all the changes are made in code. So I want to update a setting, I want to change a registry setting. Well, you don't log onto the server and change it, you do it in code through your configuration manager. I want to set SSH to only run on protocol 2. Well, I don't SSH in and change the config file and restart the service. My configuration manager now says to do that. And the advantage of that too is that after you've done it there, when you get to redeploy it, it will redeploy it with that state. So it's not a matter of, redeploy the server because we had a bug and we forgot to do that. Now the security team found out and they're auditing us and being painful. The configuration managers can prevent configuration drift in terms of they can detect it and say, yep, okay, it's here, this is it. So they can potentially report on it in terms of a dry run. So I think Ansible, that's -C parameter off the top of my head, where it will just say, hey, yep, look, if I ran this is what I would change, this is what's out. Or they can just remediate it. They'll just say, no, this is different. Change it back. And how you utilize that functionality depends very much on the business or the application you're doing. For example, if you've got a very business critical application, maybe it's not a good practice to just go through and remediate it immediately in the middle of the day. Maybe that application is better suited to, oh, yep, this is going to do it, and then go back to the application owner and say, well, what's the impact of this change? Because you may not know, and you should find out before just making it correct. Compliance managers are sort of tools that will just check the compliance against a desired state. So they the tool itself isn't designed to remediate. So there's a slight difference between a configuration manager and a compliance manager. So if using Chef as the example, the Chef configuration manager will say, hey, this is different, I'll change it back. Whereas if you use their InSpec product, it will say, this is different, and what format do you want me to do that in? Do you want me to give that to you as a JSON file, like a JSON string, or just tell you about it on screen? So it won't make that change for you. And infrastructure code leans more to that described state of this should be here, this file should exist. If I was to go back a few years, when I supported an accounting practice, they used MyOb, and they had a document store where you could browse documents, and traditionally they would use it through they had a legacy setting from there where they could browse it through Windows Explorer, and every time you did an update of MyOb, I think outside of a hotfix update, it would disappear. They'd lose the functionality, so you'd have to manually go through and do it. Now, because this didn't happen that frequently, and because working for an MSP, it was a step that was often missed. Now, if you were taking an infrastructure as code point or using a configuration manager point here, you could say, well, this file should exist and it should look like this. So the file would always exist. It would change a setting from yes to no. Like literally, that was the problem. So you could use a configuration manager to do that, and then you could dry run, have a scheduled dry run to run every 24 hours just to make sure. Now, traditional steps as well, they don't usually, when you go from a traditional scripting point of view, someone writes a script and, hey, cool, this script works, and they just pass it out via email, and someone modifies it, and then they've got their own version of the script, and then someone else has their own version. Or if they put it on a network share, then you'll have, spin up VM-1.ps1, spin up VM-old.ps1, spin up VM-back.ps1 for PowerShell scripts, and it doesn't take into a lot of those processes. Also, quite often they're written just by someone just trying to get a job done quickly because they've done it a few times. They maybe never intended for it to be a fully functional, fully business thing. It was just something easier for them. So things such as verification, unit testing, those sort of practices there may not be included in that code, and they haven't had to take that into account. And this also goes for the security side of things. When you look at infrastructure as code, if you have to touch multiple systems, you need to have those credentials stored some way. And that they may think, well, because I did it as a traditional script, they'll just have a prompt. It'll just say, hey, here's a prompt for a secure string for this password. They may, hopefully they didn't, just put the password in there. Or just a local path to an SSH key. And ideally, though, they don't commit that SSH key to a public GitHub or a publicly open S3 bucket, which happens more often than people want to think about. Actually, there's a good one for your best practice. Make sure that when you do Git pushes to a public or any remote repository, that it automatically pulls out any credentials or SSH keys.
Yeah, it's kind of scary to think there's bots that scan all public GitHub repos for that so they can hack your account.
Indeed. And you can actually automatically parse those details out of there. So, yeah, have a look into that one. And often with the traditional scripts, because they don't take into account the application configuration, as things change, that script may just sit there and it's like, okay, well, I've deployed this in this way, and now I have to go change these things. And as time goes on, well, these things that I have to change take longer, or just get forgotten about because someone gets told that, hey, this script's easy to use. So infrastructure as code, when it comes down to it, it's very descriptive. I want it to look like this, and despite the fact that I've mainly focused sort of from the application side, this does affect, I want my hypervisor host to look like this, or I want my network switch or my security group to look like this. It's the same thing as describing it. Now, what you can describe in a configuration manager depends on what's written underneath. So, for example, if I have a configuration manager and I just say, hey, look, I put in a resource name. The resource is install package, and then I say package name. I think one of them is install Windows feature. Maybe that's my resource name, and I just put in or Windows feature may just be the resource name actually, and then I just put in the name of the thing. So it might be IIS. I just say, name is IIS, and present should be absent, which means it should not be installed. And it will, if it sees it there, it will run through the uninstall process and remove it. Or present should be true, and it will go through and it will install it. Now that installation and those commands run for the installation aren't magic. Somebody has gone through and they have written that abstraction between running install-Windows feature with the relevant commands to do it. Based on your input, somebody's had to do that. And where this becomes important is you're relying on somebody having that. Now, if you've looked at an example, this could be for with Cisco with their UCS, they have an Ansible plugin. And if you look at the GitHub page for their Ansible plugin for the UCS manager, Ansible module, sorry, for the UCS manager, you'll see that there's a heap of things that still aren't there. And the reason for that is they haven't yet gotten to the point of going through with their Python SDK for UCS Manager and added that in. Like, they haven't converted that to where it could be descriptive. So this is where you can sort of help contribute to these open source projects. So it's like, oh, well, I need to do this. Maybe if we stick with UCS example, I need to be able to do service profiles, and it's not available on the Ansible module, and I can't see that on their roadmap. Okay, this is where you can contribute, where you sort of get more, where you definitely are a lot more advanced in it, and you write the module and then you contribute back to that program. Or if you aren't to that point yet, maybe you have to find a way to put that in there as a non-descriptive task, as in terms of, oh, now I call another script and it will run that for me. There's ways around it, but it does definitely make a break in the flow of the actual process. So I think we're going on a bit on about tools and that sort of thing at the moment. So with orchestrators, they're usually fairly big, quite powerful tools, and especially around logic. With REST APIs, it makes them a lot more universal these days. But what you'll find is tools for infrastructure as code are usually very task specific. You do this, you're a provisioner, or you're a configuration manager, or you're a compliance system, whatever it happens to be. They're very specific. And so to get that end to end, you need to string them along somehow and possibly put some logic in there at each stage to convert outputs into inputs for the next stage. And this is where orchestrators can come in, or where they do come in terms of they'll put it together. They may give you a front end like a schema to say this section will help you visually represent it. They may have integrations to other systems where you can treat that as objects. So if you're familiar with object-oriented programming, where it's just like, playbook.name would give you the playbook of a name, and you can treat it in that regard. But yeah, they usually they help a lot with that, and they can add a lot more logic to your workflows, sometimes without cluttering the actual cookbooks or workbooks or whatever part of it has to be. Sometimes you can help with that as well, and they can run verifications. Maybe you might do more error handling in that. So after each task, it runs a verification, and so they orchestrate that process for you. You may have that as the front end. So you may go into your orchestrator and say, do this, build this new virtualized data center because we're going to do something else. And the orchestrator will do it. Or you may have another system, a build system, call the orchestrator to do the task for you. Just really depends on the actual system and what you need it to do. So pipelines such as Jenkins are usually used to ship code from one environment to another, and they can be fairly difficult to learn depending on how well you grasp it. So they're a big part of that CI/CD pipelining. And part of this is, though, from a low level or from a sort of a high level point of view, you'd use a pipeline just to say, hey, look, I've made a commit, and locally, and great, it's all good. Now I want to push it to. Actually, I'm happy with my branch. I've done I'm using Git. I've got a branch here of dev, and I'm happy with these changes. And my unit testing is okay. I want to push that into master. And you could use a pipeline to say, okay, well, here we go. We're going to build some environments. We're going to do some tests. These are the test suites we're going to use. I might, talk to the orchestrator. I might just do it myself through API calls, and based on the test that I'm given, I will give it a pass or a fail. And you can see by breaking it, usually they'll break it into stages, and you say, okay, well, at this stage it failed. That's why it didn't go through, or this test failed. And that's where the pipeline comes in. They're really good because you do want to have test, dev, and master, or test, dev, and production sort of environments where there has to be verification going from one environment to another. It's a very important part of infrastructure as code, is making sure that you can thoroughly verify things, because you don't want to make the assumption, yes, it's worked because I just put in a description and, there was a bug and it didn't work as I expected, or I thought this would, maybe I've got host names and I'm going to deploy 5 servers. So I have server 01 through 06, and that iteration didn't work, and it didn't count. It tried to deploy server 01 5 times. Or maybe I forgot I forgot to put the condition on my loop that says, hey, stop at 5, and it tries to deploy 700. So those sorts of things there are where you can help pick those up. In terms of tools, so with writing code, you've got IDEs, and now these are usually based on the language. For example, JetBrains, for example, you got things like PyCharm for Python, RubyMine for Ruby. Those sorts of things. Usually an IDE is more centric to the actual language you're working in, whereas a text editor such as Visual Studio Code or Sublime Text and a heap of others, they'll have plugins to help support languages and highlight the syntax for you, but they may lack certain debugging functionality, for example, or how to manage it as a whole project. So depending on what you need to do depends on sort of what's going to be more suitable to you. Usually a text editor is going to be much more lightweight than a full-blown IDE, but there may be some functionality you require in one or the other. With version control, Git is obviously going to be probably a major part here for you. Tool specific, so this comes back to what I mentioned before, where sometimes tools will have their own version control internally as well, which your commits to the actual Git repository may vary in terms of their version number to what's actually pushed to the application. Build and test tools, so things such as Jenkins, vRealize Orchestrator or vRealize Automation for actually running the workflows and orchestrating. InSpec from Chef helps with the testing from the client's point of view. Terraform, Heat, or Terraform's built as an infrastructure as code tool to help just deploy everything in the same state every time, and you hit destroy and it goes. It doesn't modify. So outside of I've added one or I remove one, that's sort of where Terraform comes in, where it'll send that configuration off to something else. And OpenStack Heat. Configuration tools, sort of your Chef, Puppet, Ansible, SaltStack, Windows Desire State configuration. And I have an example, a little demo. So this is from, and this is one that I from this link here. So give them some credit for the demo. Now, I'm really hoping that I did run it beforehand because it takes a little while to run.
I saw that it said kitchen. Are you making bacon with Terraform? Because if so, I'm going to become DevOps.
Okay, yes, definitely, of course, yes. So with this one, I'm not going to run it all the way through because it just simply takes too long, and I'm sure you just don't want to watch a whole heap of text streaming. Essentially what this does, so when we talk about building test environments and validating, this whole workflow here is using Terraform. So this is a shell script. Actually, what would be better of me? I remember the dem path now, don't I? There it is, Terraform. So within this, not going to go all the way through all the detail with the code, just to give you an idea though of how this goes through. So this uses Chef's Kitchen or Chef's Test Kitchen to make bacon. Verify your deployment, and basically what it does is it runs a few kitchen commands and it'll build up the environment using Terraform. So this is a plugin they've developed for Terraform, and essentially where I can use this is I've got a environment, I want to build it up to see if it will build, and I want to make sure certain criteria are met, but I don't want to be billed for it outside of it. So I don't want to have to continually use resources for this environment to exist. And the other advantage of this sort of approach is that each time you spin up the environment, it's a clean environment. It doesn't have crap left over from all your other testing. Just to quickly skim over it, so it's going to create things like your availability zone, or it's going to use an availability zone. It creates a key pair in AWS, so it doesn't exist outside of this test after it destroys it. It'll, create instances, and it'll come through here. We got security groups, so the AWS security groups to control all the security policy as well. And these can also be used to, when you say, well, I want to test, and they go, well, what if that impacts production, or whatever it happens to be? So, well, here's how it's isolated if that's another requirement, and essentially then it will go through and it will it'll run some tests after it creates it. We can go through and you can see here's a failure. I've got one passed that the operating system matches, so that was one of the tests, and then one failed that they can't reach each other. Depending on the point of the thing, that may or may not be a problem, but that's sort of where you can do that testing. Whereas with one command, I can spin up the whole environment, run tests, see if it passed or failed, get a coffee while it happens, come back, okay, it failed. Well, let's go have a look at our tests. Let's run some different tests now because they didn't work. So as part of my process before I push this out, this is sort of the kind of thing that would happen. And the advantage of doing it this way is you could run this test once, you could run it 50 times, because part of testing is not just ensuring things pass, but it's also about ensuring things fail where you expect them to. So, if I have special characters in my names, maybe I have a test where I try to name a VM starting with an @ symbol, and I know that that's against AWS naming policy, so I want it to fail, but I need to make sure that it's captured because we don't want that to happen. Or I want it captured that certain names that we have reserved for something else, certain name prefixes, that it will stop that, and I want to make sure that happens every time. So that sort of failure where it would raise an exception, well, that's exactly what I want it to do. So testing is not just about, hey, look, it passed and I got green ticks everywhere. It's what failed that I expected it to fail. Now, in saying that, you can actually have your test say, expect failure, like expect that this does not happen, and it would still be a pass, but you've written it in there that this is a condition that, meeting this condition. So yeah, that sort of wraps up sort of a lot of what I had to say about the infrastructure code point of view, and sort of more concepts around where you might try to get started, have a look, and some of the challenges around it too.
Cool. Thanks, Brett. Just as a shameless plug, we also have some videos on Terraform, including Grant Orchard going through kind of an introduction to Terraform, which kind of dovetails nicely from your session here. So if you want to learn more about how to use Terraform, just check that out on the YouTube page.
Cool.
So Larry Smith has tweeted out some automated templates for vSphere out on Twitter. So check out Larry Smith on Twitter, and I've retweeted it. We'll make sure to get that out there for everybody.
Very nice. That's what my phone was lighting up about. All right. That's sort of all I had for that. Is there anything else you need to add there, Tom?
No, Twitter's clear and the questions are clear. Just thanks for the great intro. Thanks for all the work.
Thank you for letting me present again, and having to decipher my accent.
Well, we all have an accent to somebody, right?
That's it.
All right. Well, thank you, Brett, and thanks everyone for joining us. Next week, I don't think we're gonna have anything on the calendar, so check back in a couple of weeks.
Cool. Thanks, everyone. Have a good night.